In 1960, a physicist named Eugene Wigner published an essay with a strange, almost embarrassed title, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Wigner wasn't religious, and he wasn't trying to make a theological point. He was simply confessing, as an honest working physicist, that something about his own field deeply unsettled him. Mathematics, he pointed out, is a human invention. Abstract symbols and logical relationships that mathematicians dream up in their own minds, often with no application in view at all, purely because the ideas are elegant or interesting. And yet, again and again, these same abstract ideas, invented for no practical reason, sometimes centuries before anyone found a use for them, turn out to describe the physical universe with breathtaking precision. Wigner called this a gift we neither understand nor deserve. Today we're going to sit with that strangeness, because the question underneath, why does math even work, isn't a small technical curiosity for specialists. It's one of the deepest, most under-discussed puzzles in all of science. And some physicists have looked straight at it and used the word miracle without any embarrassment at all. Let's start with what makes this puzzle so strange in the first place. When a mathematician works out a new theorem, they're usually not looking at the physical world at all. They're following pure logic, starting from a set of assumptions and working out what necessarily follows from them, purely inside the world of abstract reasoning. Non-Euclidean geometry, for instance, was developed in the 19th century as a kind of elegant intellectual exercise, exploring what geometry would look like if you dropped one of Euclid's ancient assumptions. Nobody developing it had any physical application in mind. And then, decades later, Albert Einstein needed exactly that kind of geometry, curved, non-Euclidean geometry, to describe how gravity actually works in general relativity. Because it turns out, massive objects genuinely do curve the fabric of space and time in precisely the way that useless 19th century mathematics had already worked out. The math came first, developed for no physical reason at all, and reality later turned out to be built on exactly that structure. This isn't an isolated case. Imaginary numbers built on the square root of -1, which sound like they shouldn't correspond to anything real at all, turned out to be essential to quantum mechanics, describing the actual behavior of subatomic particles. Group theory, an abstract branch of mathematics about symmetry, ended up predicting the existence of entire categories of subatomic particles before they were ever detected in an experiment. Physicists didn't go looking for math to fit an existing observation. In case after case, the math was there first, waiting like a lock built long before anyone had made the key. Here's where it's worth pausing, because a lot of people hear this and shrug. Of course, math describes the universe. That's just what math is for. But that response skips right past the actual mystery. Think about what a purely materialist, non-designed universe would predict. If the universe is simply the product of blind physical processes, with no mind or intention behind it, there's no obvious reason it should be governed by clean, elegant, discoverable mathematical relationships at all. It could just as easily be a universe of brute, arbitrary facts, inconsistent from place to place, resistant to any tidy formula, the kind of universe where you'd need a different, unconnected explanation for every different phenomenon, with no underlying unity tying them together. Instead, we live in a universe where a small set of remarkably compact equations, Einstein's field equations, Maxwell's equations for electromagnetism, the Schrödinger equation for quantum mechanics, can each be written on a single line, and each one accurately predicts an enormous range of physical behavior across the entire observable universe. That's not a small thing to explain away. Physicists routinely describe these equations using words like beautiful and elegant, aesthetic language borrowed from art criticism, applied to descriptions of raw physical reality. That's an odd vocabulary to reach for, if the universe really is just an accident of particles bumping into each other with no underlying order behind it? And there's a second layer to the strangeness. Human minds evolved on a purely naturalistic account to help our ancestors find food, avoid predators, and navigate savannas, turn out to be capable of understanding quantum field theory, general relativity, and the geometry of 11-dimensional string theory. There is no obvious survival advantage to being able to grasp the mathematics of black hole thermodynamics, and yet, our minds can do it. The fit between abstract human reasoning and the deep structure of physical reality goes far beyond what raw survival would ever have required. This isn't a fringe observation dreamed up by outside critics of science. It comes from inside the field, from physicists with no religious agenda to push. Wigner, as we mentioned, called it a gift we don't understand and don't deserve. Strong, almost worshipful language from a scientist simply trying to describe his own discipline honestly. Einstein himself once remarked that the most incomprehensible thing about the universe is that it's comprehensible at all. That a small, curious species clinging to a mid-sized rock in a mid-sized galaxy should be able to reach out with pencil and paper and accurately describe the behavior of stars we'll never visit and particles too small to ever see directly. Some physicists have tried to resolve the mystery by proposing that mathematics isn't really invented by human minds at all, but simply is the actual fundamental substance of physical reality. The universe on this view isn't described by math. It literally is math, all the way down. That's a genuinely interesting idea, but notice what it does. It doesn't remove the mystery. It just relocates it one level deeper. You still have to explain why reality would be built on a foundation of clean, comprehensible, rational structure in the first place, rather than brute, arbitrary chaos. And you still have to explain why finite human minds happen to be capable of tracing that structure out. Here's where this puzzle connects back to the theme running through this entire series. John's Gospel opening with the Logos, the divine reason behind everything that exists. If the universe is the product of a rational mind, then it's exactly what you'd expect to find a rational mathematical structure underneath physical reality, not as a strange coincidence, but as a signature. And if that same mind made human beings in his image, with minds capable of reason and abstraction, then it's exactly what you'd expect that those human minds, however imperfectly, would be capable of tracing out at least some of that underlying rational order, because the reasoning capacity woven into us echoes, in a limited way, the reason woven into the universe itself. That framework doesn't require you to treat the mathematical elegance of physics as an unexplained brute fact you're simply not allowed to ask about. It gives the mystery an actual explanation, not math just happens to work. Don't ask why. But math works because a rational author wrote both the universe and the minds capable of reading it, using compatible language. So why does math even work? It's a question that sounds almost too basic to ask out loud, and yet it sits underneath every equation ever written, mostly ignored because it's simply assumed. Wigner didn't ignore it. He looked straight at it and called it a gift science can use, but not explain. Maybe that's because it isn't ultimately a scientific question at all. Maybe it's a theological one, hiding in plain sight inside every physics textbook. A rational universe, comprehensible to rational minds, because both were spoken into being by the same rational word. Thanks for watching. If this gave you something to think about, consider subscribing, and I'll see you in the next one.